Good afternoon. I'm Jay Scott, editor of ASHRAE Journal. Thank you for joining us for today's webinar, part of the Journal Supplier webinar series, providing information about products and technology for industry professionals. ASHRAE does not review supplier webinar presentations. Schebler Chimney Systems presents today's webinar, Grease Duct Systems Designed for Code Compliance and Fire Safety. Today's presenter is Mike Mommsen. Mike has been with Schebler since 2008, providing technical consultation to engineering firms, building owners, and boiler manufacturers. Mike has worked extensively with Schebler's experienced engineering and design staff to communicate and coordinate design practices that meet ASHRAE, IMC, NFPA, and ANSI requirements. Mike has also developed relationships with boiler HWH manufacturers to assist engineers designing venting systems specifically for complex, high-efficiency appliances. And now we turn the presentation over to Mike. Thank you.
Thanks, Jay. Before I start real quick, if anybody has any questions during this presentation, please submit them to the Q&A box on your screen. We will try to address as many questions during the presentation and directly afterwards. And if we're not able to get at your question during or after presentation, we will make sure we address it here real soon. So today's presentation is about grease duct systems and design for code compliancy. So I kind of want to start out with some real quick data from NFPA research. And I want to apologize for this data being a little bit dated, but it talks about structure fires in eating and drinking establishments by major cause, and basically data is generated from 2010 to 2014. But a note here is that deep fryers were involved in 1 of 5 fires, so 21% of fires in eating and drinking establishments are caused by deep fryers. Fortunately, 2/3 of those were basically limited to small and did not go beyond the origin of the fire. But a note is that a failure to clean was a factor in 22% of the fires in these properties, to me, which would be directly related to deep fryers where we're producing grease-laden vapors. So since today we're going to talk about grease duct systems, I want to kind of give a real quick definition or use International Mechanical Code basically to clarify what is a grease duct system and where it would be applied. So there are 2 types of kitchen hoods for commercial kitchen operations. A type 1 hood is one that would collect and remove grease vapors and smoke from grilling operations or frying. And such hoods would be equipped with a fire suppression system. And because they are venting out grease vapors and smoke, they would be required to have a grease duct system from connection to that hood with fire suppression to the termination of the system. Type 2 hoods would basically be for removing steam, vapor, heat, odors, process combustion, but they wouldn't carry grease-laden vapors, so would not require to have a grease duct system attached to them. So when it comes to grease duct systems, there's really 2 parts of fire safety and protection to deal with it. And that's really what we're going to deal with here is how ducts are constructed to make sure they're fire safe and code compliant. So the 2 safety factors when it comes to grease duct is one would be grease duct fire. I've got these grease vapors getting into the hood or into the duct system, and they may collect. And if we have a fire that would start from grease being inside the ductwork, we have to make sure that the duct system, has a proper clearance to combustible so the fire inside the ductwork doesn't start the surrounding structure on fire. Second would be containment of that fire inside the duct. Obviously, we don't want a fire inside the ductwork, but if that would occur, the goal would be to contain inside the ductwork, either suppress with fire suppression equipment or have it burn on its own and not burn the rest of the building down. The second part of fire safety and protection would be in the event we have a kitchen fire. So something else in the kitchen starts on fire. Maybe it is the fryer or the grill. But what we don't want the grease duct system to do is to allow that fire in the kitchen area to go through the entire building. So with the fire resistance rating, we're really paying attention to the structural integrity of the ductwork itself, and then the fire stop system as it penetrates either through a ceiling or into a chase or surrounding areas of the building. Now, when I think of grease fires, I tend to think of single-story restaurants, the fast food restaurant that's, doing a bunch of grilling, doing a bunch of frying. And if you start, looking at the local news and papers, you can see a lot of places where, the local, burger joints start on fire. The thing with that is typically we're talking single-story building, relatively low occupancy, the staff, some dining customers, but it's a pretty low risk of life and danger because of the construction of the building and being single-story. Nowadays, though, in a lot of construction, you're starting to see mixed-use developments, a lot of downtown development, a lot of high-rise condos, and there's a lot of mixed use with retail and restaurants in those condominiums or apartments. So now I'm talking about having frying or grilling operations in a commercial kitchen with basically a high potential risk of loss of life by having several floors of occupancy above that. We also see a high risk when we talk about healthcare systems. So we've got commercial kitchens, obviously, in hospitals, long-term and rehabilitation facilities, nursing homes, with a lot of cooking hours based on the number of meals they're preparing there for the entire staff of the facility. So fire safety is extremely important when we look at doing system design for any healthcare thing, because obviously evacuation is really tough in any of these facilities as well. So let's look at what the requirements would be to design and construct a grease duct system. So we're going to really look at codes and standards that are out there for reference for proper system design and construction. And we're really going to look at International Mechanical Code. I kind of put the International Mechanical Code all the time in this presentation. Uniform Mechanical Code also addresses grease duct systems, but if you look at them side by side, they're almost comparable, so I didn't feel it was pertinent to have both in here. National Fire Protection, NFPA 96, talks extensively about grease duct systems. There is reference in both of these to ASHRAE ANSI Standard 154. And then there's an engineering standard 2336, which also addresses fire resistance ducts for grease ducts. The key to note is the authority having jurisdiction is going to look at local codes, which are probably based off of International Mechanical Code and NFPA, and also will reference the codes I mentioned above. And it's really up to them to reference interpretation and enforcement of these codes when they're inspecting systems. So the key is when we look at system design and construction, you really have to reference several of these codes and standards to ensure if you're going to design a system that you're going to be able to have authority having jurisdiction approve of the system design. So let's look real quick at International Mechanical Code and see what's in there about duct construction. So it's basically going to state again, duct serving type 1 hoods need to be built in accordance with their section 506 3.11. And in that section, basically, they're going to dictate what gauge and type material is going to be acceptable. So for field fabricated grease duct, it can be of carbon steel, a minimum of 16 gauge material can be utilized. And if the contractor or engineer specifies use stainless steel, 18 gauge would be the minimum thickness that could be applied. Now, the exception is those gauge materials is to utilize a factory-built commercial kitchen grease duct product that we listed and labeled in UL accordance with UL 1978. And we'll definitely hit on that UL listing later on. Fire-rated shafts, if I have a grease duct that's going to be in a building that is multiple stories, that grease duct needs to be inside of a fire-rated shaft. Again, as I mentioned before, we're trying to protect the fire from spreading from a kitchen area throughout the rest of the building. So in a building that's greater than 1 story, a fire-rated shaft would need to be constructed to have that grease duct in. And that fire-rated shaft can only serve a single grease duct. So if I had a high-rise condo building and I had 4 or 5 different hoods in different areas of the kitchen, and I had to route those to the top of the building, that means I had to have 4 or 5 separate fire-rated shafts to run those grease duct systems in, and then nothing else could be inside that shaft. So you can imagine the amount of space and cost would be to do that inside of a facility. So the fire resistance rating that shaft would have to have for International Mechanical Code, we would have to have at least a 1-hour fire-rated shaft to comply with the code. NFPA is going to be a little more stringent when it talks about fire resistance rating of shafts. It's going to tell you a building that is less than 4 stories, we can get by with a 1-hour fire rating. But a building that would exceed 4 stories would have to have at least a 2-hour fire rating for that shaft. Now, how do we get away from shaft? Several years ago, code allowed, either a field fabricated grease duct system that was designed and constructed per the engineering standard 2336 to be considered its own integral shaft and chase and not have to have a fire rated shaft to be routed in. Or a factory-built UL classified 221 product could be utilized, allowing us to not have to use a shaft. Now, the shaft not only provide protection for that fire to spread from the kitchen to the rest of the building, but in essence, it's also a safety barrier if that ductwork has some kind of catastrophic failure with the fire inside of it to keep from spreading inside the rest of the building as well. So you really look at a shaft as two parts, I guess. One is in keeping the fire from going to the kitchen, and two is if you had a catastrophic failure of the ductwork, if I'm in a fire-rated shaft, that's also going to serve as some level of protection because that fire-rated shaft would only have one grease duct and no other components inside of it. So for this presentation, since we're talking about fire rating, I'm really going to focus on design and construction and factory-built products that would look at zero clearance and fire-rated systems that we could utilize in a multi-story healthcare building or a apartment or condo type building. So field product would be constructed of carbon steel or stainless steel. A fire protection wrap of certain application would need to be done for fire rating and zero clearance, and or factory fabricated products with the UL listing. So on the field fabricated ductwork, to determine proper construction installation, again, we'd have to refer to International Mechanical Code, NFPA, ASTM for an engineering standard for that, and also UL and ETL. Insulation manufacturers do a lot of testing with UL, Intertech, and testing to engineering standard to rate their products to be utilized for this application. So on construction of the duct itself, again, International Mechanical Code also addresses the duct material that need to be utilized, but they also address joints, seams, penetration of the ducts, the joint types, hood connections, duct exhaust fan connections, vibration isolation. While they're addressed in the International Mechanical Code, there's not a lot of detail in the code on pure construction. So I'm going to kind of skip past it instead of reading all those sections to you, and we'll kind of hit on NFPA with a little more detail. Now, field fabricated systems would have to go through a grease duct test prior to any kind of covering of coatings or wraps that would be done. So that testing would be done as a light test to determine that all weld and brace joints are liquid tight. In essence, they would take a 100-watt light bulb inside the ductwork and visually make sure that no light would be visible on the outside of the ductwork and into weld seams of the system. Supports mentioned in the National Mechanical Code, it's very vague on exactly how this thing should be supported. Really basically pulling from the National Mechanical Code, as long as the structure is able to carry the load and seismic loads and stresses, stress in National Building Code, we're going to say the supports are acceptable. And then they will note that bolts, screws, rivets, and other things can't penetrate the ductwork, but it's really vague on what those supports should look like to properly keep the ductwork in place, especially in the event that we would have a fire, either in the kitchen or in the ductwork. Now, if we look at NFPA and what it states about construction of the ductwork, it's pretty much going to reiterate what our National Mechanical Code says. Have another reference back into UL 1978. It is going to be a little more talking about seams, joints, and penetrations, that they have to be a continuous liquid-tight external weld in the ductwork, not an internal. Factory-built products would be permitted to be non-welded as long as the joint construction in the field was done per their listings. And then also notes in there, prior to concealment of any portion of the grease duct, a leakage test would need to be performed to ensure that all weld joints were liquid tight. Now, NFPA 96 is going to give you a little better example of acceptable weld joint types, whether it be flange with edge welds, fillet welds, bell-type overlapping joints, and then some pretty detailed construction of how you would construct the ductwork to the hood itself to be considered acceptable to NFPA 96. Another source for construction of ductwork would be the information published from the insulation manufacturers. Insulation manufacturers have paid and conduct several tests to certify that their insulation is going to be suitable for use for grease duct. So if you look on the left-hand side there, they'll publish that they've done testing through Intertech Labs, UL, testing per the ASME standard. But in their information, and it might be different based on which manufacturer's information you reference to, there is some reference to maximum duct size. A recent document I pulled up the other day indicated that a 40-inch square inner surface area of the ductwork would be the maximum acceptable that would be able to be utilized with their fire wrap on the procedure they gave. Some other manufacturers indicate a maximum side limit of 48 inches. I believe the still same square inch internal was the limit, but you could go with the max limit of a 48-inch diameter on one side. Hangers and spacings, there's a reference to a spacing of possibly a maximum of 60 inches. And then interesting note, I was able to find a note that vertical supports on ductwork that will be going up the building, inside the building, would need to be located on every single floor. I have yet to see that in construction, but it's pretty interesting to note that per the testing they've done, that was a requirement of them. Application of the insulation to be considered fire rated would really be found in ASME 2336. And that information is going to be, the testing done in ASME 2336, the insulation manufacturer is going to publish how that should be conducted so to meet the test requirements they've gone through. So based on the aspect ratio of the duct, so the inner surface area, and also how they're going to support this, there's going to be several methods of banding, pinning, overlap of the insulation, overlap of the seams of the insulation to make sure it complies with the engineering standard to allow you to be utilized as a fire-rated shaft. Now, field fabricated products, they'll be considered zero clearance and fire-rated. Would need to utilize a UL 1978 listing, which gives a product a grease duct listing. UL 221 classification, which is where the fire rating testing is done. These products are almost exclusively constructed of stainless steel inner liners, ceramic fiber insulation, and then an outer shell, which can usually be stainless steel or maybe aluminized steel. These products are modular components and have a mechanical joint connection, which wouldn't require any field welding. Now, a UL listed product is going to also include supports, guides, hangers. So it's a system that's gone through testing of all the structural components. So you really have a pre-engineered system. So under UL 1978, amongst all the tests you go through, it would go through a structural integrity test and make sure all the supports of the vertical duct, hangers for the horizontal, would all be included in that testing to make sure they can withstand the weight of the duct, withstand a potential grease duct fire as well. An internal test would also be done with temperatures considered to be high as a grease duct fire to determine what our clearance combustibles would be. And then I think really important to note that UL listed products will go through actual leakage test with UL. UL physically is going to assemble your ductwork and basically create a grease duct fire inside of your system. So your product is going to be subject to the temperatures, the strains of thermal expansion, the liquid grease inside of it, and ensure that all the joints, construction rubbles and stuff can withstand an actual grease duct fire. Now, to have a fire rating of product or to obtain zero clearance, a product would need to go through a UL 221 classification. So for zero clearance, again, we go through an internal temperature test, and to receive a fire rating, you would go through an external testing of the product itself. So on the internal test, you're basically going to subject your grease duct to temperatures equivalent of a severe grease duct fire and hold that temperature for a set number of time while the outer shell is being measured for proper temperatures for clearance to combustibles. To receive a fire rating, the external test, basically a section of ductwork is going to be L-shaped, is going to be assembled and attached to a concrete slab to represent you're securing this grease duct to a building structure. So this test is going to test not just the ductwork itself, but also the supports, the hangers, the through floor or through shaft penetration. It's going to be an overall test of the structural rigidity of that ductwork to be able to resist a fire from going through that ductwork, around that ductwork, to the floor above it. So once a product's assembled, it's going to sit in the oven, and it's going to be subject to temperatures to simulate a grease duct fire while the duct is being pressurized to make sure that it can maintain a certain level of pressure and stay structurally intact with the temperatures that it's being subject to. And then once you've maintained or passed that section of the test unit itself is going to be lifted out of the oven, and then it's going to go through a spray test or a fire hose test where basically they're going to blast the ductwork and the support structure with the fire hose to make sure that it structurally stays intact to the concrete floor in the event that the fire department's in there putting out the fire and it stays structurally intact. So it's a very, very strict and very difficult test to pass. So let's do a quick comparison of field fabricated grease duct versus UL listed and classified. We're going to look at the construction, the system design, the installation methods that are going to be utilized, the facilitation of grease if it does enter the ductwork, which we know it does at times, so we'll look at slope, cleaning methods, and then testing and inspection methods that will be done in the field to verify that it's installed properly. Okay, as we covered earlier, if I'm going to assemble or construct a grease duct system in the field, I'm going to need to refer to all the codes and standards above to ensure that I'm going to be providing a safe system. So again, International Mechanical Code, NFPA, Engineering Standard 2336, and or per the installation manufacturer's instructions, the UL or ETL instructions that are part of it. So field welding of ductwork, joint construction to be compliant with that, and structures and support would be included with that. The difficult thing would be is since there is no one single definitive guideline for any of this, no single one guideline for construction, no single one guideline necessary for installation, it would become really difficult for anybody to automatically walk onto a job site and ensure that that ductwork is constructed within the confines or the thought of the code. And there's going to be a lot of areas ductwork's going to be really hard to inspect because you're inspecting everything in place up in the air, and it's going to be really difficult to go back and do some installation as well once it's all assembled. So the real question to me is with field fabricated is how confident can you be that all the critical steps have been taken in the construction installation thing to make sure that I'm getting the fire protection that the installation and stuff was tested to originally. Factory products are UL 1978 and 221. I mentioned this before. Modular construction, stainless steel. A mechanical joint connection that can be easily done in the field. They're double wall and they're factory built. So the construction is done in a controlled environment in a manufacturing facility. And the installation is all installed at the factory per the UL listing to make sure we've got adequate coverage. And then it's protected with an outer shell to make sure that it stays intact in transportation, during installation, and even testing in the field. So if I look at the installation of a wrapped ductwork, I really have concerns about its durability. So now I've got fiber insulation, foil wrap on it. It's really critical that that insulation be in the right place and be intact to be able to perform its duty to remain as fire protection as it should. So it's really easy if they're in there doing other trades while this ductwork is in the facility, when they're in there cleaning the systems. It's a lot of risk of damage to that insulation out there. A double wall product has much less risk of damage on site or damage as the system is being hopefully inspected and cleaned on a regular basis. Also, from an aesthetic standpoint, if I've got exposed ductwork in the facility, obviously the outer shell is a lot more aesthetically pleasing. It could be powder coated or painted as well if I've got exposed areas of building versus a insulation with just a foil outer shell on it. There's also a significant risk of grease duct systems of buildup of grease inside of them that would prevent a fire risk. So if you look at the little chart on the left-hand side, air tends to flow in a circular pattern inside of a duct system, especially inside of a grease duct system. And by having a round duct, we have much better airflow and stainless steel construction to have good airflow on straight sections, transitions, and so forth, versus a rectangular ductwork, which is going to have straight sides and broke corners, which is going to have much greater risk for collection of grease in those corners, especially as I look at changes in directions. There's going to be a much greater risk of buildup. and or risk of leaving behind residue from when they clean the system. So let's talk for a second about grease duct drainage. Per code, grease duct systems need to have provisions for grease drainage, and they are done to prevent accumulation of the grease inside the duct system. They need to drain back to the hood, which would be able to receive that grease, or back to an approved grease trap located somewhere inside that system. Now, the slope requirement to get this grease drainage is going to be noted in International Mechanical Code and NFPA as a 1/4 inch per foot on a horizontal run up to 75 feet in length. And if my horizontal run exceeds 75 feet in length, that pitch requirement or slope requirement will be 1 inch per foot. Now, there is a note in NFPA that if I utilize a UL listed manufacturer's product, I can refer to their listing instructions. UL allows factory built product to be done at a 1/16 of an inch per foot up to a 75-foot horizontal run, and then a 1/4 inch per foot if my run exceeds 75 feet. So let's compare field fabricated versus factory. If I've got a field fabricated product and I need to comply with the International Mechanical Code, if I've got a 50-foot horizontal run, and per International Mechanical Code, my pitch requirement is a 1/4 inch per foot, this is going to require this grease duct to slope 12.5 inches over that 50-foot run. Now, if I utilize a UL listed manufacturer's product and can refer to their installation instructions, as noted in NFPA 96, that same 50-foot horizontal run at a 1/16 of an inch per foot would only require me to have 3 1/8 inches of slope. So in essence, I would save almost 9.5 inches in the overall length of that ductwork just by utilizing a factory built product versus field that would require much less slope. From a cleaning standpoint, the method that seems to be most prevalent today to cleaning a grease duct system is not the guy in the right-hand corner with the scraper cleaning out the duct system. What we see most common today is coming in with a pressure wash system, either a wand type system, opening access doors or through the termination, or there's a mechanical device nowadays that are being done, as you see down there, with a brush, applying a cleaning solution that would be basically snaked to the ductwork to do the cleaning. It's much easier to obtain a good system cleaning with a round duct that's constructed of stainless steel than to try to get in there and try to thoroughly clean out the corners and change the direction of a rectangular ductwork. All right, system inspection is going to be required, or at least hopefully is going to be required by the local jurisdiction before the system is going to be concealed. And International Mechanical Code is going to call it a light test that should be done. And on field fabricated product, they're saying every single weld and joint in that system needs to go through the light test to make sure that it's acceptable. International Mechanical Code is going to exclude weld joints from factory built products and only require the mechanical joint that's assembled in the field to be going through a light test. NFPA 96 is going to reference a few different tests. One would be a light test, just like International Mechanical Code. It does make reference to a water pressure test, and then it does make a reference back to ASHRAE standard 154. So if you pull up ASHRAE standard 154, it's basically going to list out 3 separate possible grease duct tests that could be conducted that would be acceptable to local jurisdiction. One would be the same light test that was addressed in International Mechanical Code and NFPA. But the second one would be an air pressure test, where basically the system would be sealed and pressurized to a minimum of 1 inch of water column and required to hold that 1 inch of water column for a minimum of 20 minutes to say the duct is acceptable and will not leak. Now, the last test listed in ASHRAE 154 would be a water test, where basically go through and simulate cleaning operations with a minimum of 1,500 psi pressure, spray the entire system down to simulate a cleaning operation to make sure that all the joints, access points, you name it, will not leak water out to ensure that they be leak-free. All right, field fabricated versus listed products. Field fabricated products only going to go through the test that's conducted in the field. So whatever test that is, whether it be the light test, whether it be the water pressure test, whether it be the air pressure test, the only test it's going to go through is a test that's physically conducted in the field. And really that test does not simulate a grease fire. None of these tests are done under the temperatures that you would experience during a grease duct fire. So one huge advantage I feel on fire safety that UL listed products have is they physically have passed a UL grease fire test. So you can be assured, I get asked before, hey, how should we be testing these things in the field? People want to know what UL is doing to certify a product, and I say, well, you can't exactly conduct the UL test in the field because it's going to require you to create a fire inside your ductwork. All right, I'm going to kind of jump down a little bit about system engineering. Several years ago, International Mechanical Code and NFPA greatly reduced the minimum velocity when you're sizing a duct system. Currently now it states not less than 500 feet per minute. And I'm sure there's several reasons for it. One may be the fact that you see a lot more use of variable speed fans and so forth, trying to minimize the heat loss through the system. But the minimum now in International Mechanical Code and NFPA are 500 feet per minute. Now, ASHRAE still makes a note in their standard that they don't limit the airflow by velocity by having a max. They do still adhere to the 500 min, but it says it's common to size these systems at 1,500, 1,800 feet per minute. If I'm looking at sizing grease duct systems and I'm going to utilize 500 feet per minute, the grease duct systems are going to become massive to reach those low velocities. So it's still not uncommon to size at 1,500, 800. One note you'll see in ASHRAE standard is velocities greater than 2,500 start having risk of potential noise levels and so forth, and you would call maybe a tin canning effect that ductwork as I go through those high velocities. One thing you will note if I look at utilization of round factory built products, if a system did need to be sized at higher velocities to reduce the size, we have much less risk of that happening on a round product because we won't have that flat side to potentially vibrate, and then we're pre-insulated to keep that from happening. Clean out openings. These are going to be critical. Hopefully the systems are going to be going through inspection and cleaning. International Mechanical Code and NFPA are going to have different requirements for clean out access doors. International Mechanical Code is basically going to state that on a horizontal grease duct run, the clean out locations can't be more than 20 feet apart, and they're going to be required in changes of direction to make sure they can access those corners. Vertical risers, again, are going to basically state not more than 20 feet apart. And there's going to be a note in there about not required when personal entry is possible. If I bump over to NFPA 96, it's going to require the horizontal to have clean out accesses at 12 feet, 12-foot intervals, and required in changing directions. And then on the vertical riser, they're going to require them to have them on every single floor. Now, one note, they both say not required when personal entry is possible, and this is where I think it's really unclear. There's reference in there that a 20 by 20 square duct, or it could be 20-inch diameter round duct, would be considered accessible for personal entry, which, number one, people aren't getting these ducts used anyway. Number two is I doubt you get somebody to jump inside of a 20-inch diameter ductwork. Second, if you note, the difference between clean outs can be pretty drastic if the system has any size to it. Here at Schebler, we tend to design for the most stringent NFPA 96, knowing that if we had the option to remove those, if the local jurisdiction is going to allow us to meet International Mechanical Code, we can pull those out of the system. And also with the thought process is we do coordination of the grease duct system. If there's definitely places in the system where there's no access, we can also consult the local jurisdiction, hopefully remove those out of the system so we reduce the cost of the system and potential points that would be higher risk for any kind of leakage in the system. So clean out access doors on factory product can be a couple different ways, either in-on access doors or grease tees. Field fabricated products can utilize the same inline access doors that are flat as we utilize for inline access doors, and those would be cut in the system per requirements as well. So if I look at the design and who's going to be responsible for it, field fabricated products, really design ends up really kind of falling back on the contractor for the most part. I don't believe most engineering firms probably detail out a grease duct system, and the sheet metal contractor typically is going to be responsible to make sure that he's constructing that duct, he's got the supports in the right place, clean out access doors are acceptable to local jurisdiction. And then the insulation contractor is really going to be responsible to make sure that when he applies that insulation after it's gone through inspection, that he's doing it compliant with the insulation manufacturer's published information. So it's really dependent on proper construction that's going to be performed in the field. On the UL listed label product, the design is going to be done in accordance with its listing. So horizontal hangers are going to be placed in positions that are part of the engineered testing that's done at UL. Vertical support is going to be done. The constant monitoring of UL of our construction processes and fabrication processes are going to be adhered to when a product has a label on it. And then it's really easy from an installation standpoint on a factory-built product when you have a drawing that is designed by us and has UL compliance to it, to easily inspect the system to ensure that it has the components in the right place and has all the integrity to meet the UL listing that it's designed for. One struggle we all have with UL-listed fabricated products is most overhead space is designed for ductwork end up being rectangular, whether it be air ducts or whatever. And now factory-built products for grease duct are coming out of factories round. So in essence, we're trying to put the round peg in the square hole. So one thing Schebler's done is obtained and developed a product that has a UL listing classification that is eyebrown, which we term as slim vent, to allow us to fit in the same space as rectangular ductwork. And in conjunction with our round product allows us to do a complete UL listed and classified system that doesn't require any field welding and that has all the grease duct fire safety that you have in the UL listed product. So kind of give you a whole summary here. UL 19 series listed and 2-to-1 class of products really ensure proper performance and maximum fire safety that you may not be sure you're going to get with a field fabricated product. Easy to inspect. There's simple installation instructions and drawings for the code official to evaluate and approve. It's code compliant. All local codes, if they're even within the last 10 years, are going to recognize UL listing and classifications. The complete design, which is going to come out of the manufacturer, really takes the load off of the engineering firm or the contractor to make sure that they've got the system designed to be code compliant. By reducing the slope, we can reduce space, and having round on round product, we can reduce the amount of footprint we're going to take from that building for it. And we also have less risk of buildup in the system. So the system is going to be much easier to clean. It's much safer. It's really going to give the customer peace of mind. The system's going to last for a long time based on stainless steel construction as well versus carbon steel. I'm just going to finish with a couple of design examples of projects we've done in the last few years. These aren't real recent projects, but projects that had some specific design challenges. Massachusetts General Hospital, we did a grease duct system here a few years ago. It was an additional tray line to the ground level section of the hospital. So the hospital is already occupied, so doing field fabricated welding in the hospital was not a good option at all for this particular installation. So factory-built product with mechanical connections is ideal. We had a very tight space to fit this ductwork in, and there was no place to do a fire-rated chase to route the ductwork. So we would need to find an area in the building we could route this straight up to get the fumes of the hood out of the building. So we also had very limited ability to slope this system. I'm going to show you some pictures of installation, but basically the grease duct ended up having to be flat oval and sandwiched right up against the ceiling of the kitchen area. So as you'll see, we're basically sandwiching this right up against the ceiling structure. UL Cleon access doors are designed in the system per code requirement. Factory provided hangers for the horizontal runs are there. Really tight space to fit in. This was a really good choice for this particular project. Another project that kind of a mix of space requirements was when we did University of Arizona, an end zone modular project. We had multiple hoods in several concession areas that had some real space requirements that drove us to utilize the flat oval product in the kitchen area. And then once we had the kitchen area, space was available to switch off to round product. So if you see this run here, it's flat oval. And then once we get across the mechanical space here, we're able to switch over to round product because we have less ceiling height requirements. All right. I'm going to try to read through a couple questions here real quick. Any recommendation how to run ductwork? Oh, let's start at the beginning here. Okay. This one here? Okay. I'm going to ask a really tough question we get asked all the time. What is the all-in cost comparison between ULSID products and field fabricated? You've got down here 15%, 20%, just an approximation. This is the million-dollar question we get asked constantly by engineers, and we do get asked this by contractors. I'm going to use the example here. 40 years ago in boiler flue systems, or 50 years ago, sheet metal contractors would fabricate their own boiler breaching and stack systems. And as ULSID labeled and products became in existence, they quickly realized that it's a lot easier to put a mechanical joint connection together and not have to fill weld and construct ductwork, that they easily switched over to ULSID labeled products. Grease duct's kind of been a holdout. The insulation manufacturers who've conducted a lot of testing and installation stuff, they try to position themselves as the low-cost alternative to factory-built grease duct systems. System size is going to really depend to configuration on what the cost savings would be. Honestly, I can tell you, I think we compete head-to-head with field fabricated product. In some cases, almost a no-cost increase if we're really having the contractor factor his cost all in. So his time to fabricate in the shop, his time to field weld, his time to go through inspection, his true cost of supports for that system, and recognizing his true installation cost on the beginning of the project. A lot of times on installation, overall the project's bid originally and it's built all field fabricated and there's a whole installation package, and then sometimes we get compared on the backside and only a small part of installation gets split out. So I really like to think that we're almost at a wash if all costs are factored in. Okay. Question related to about shafts and clearances. What about the exterior of the building? Do ducts need to be separated? No, they would not. And if I utilize a fire-rated ductwork, they would have to be separated. So my comment about shafts would be, if I had a non-fire-rated grease duct and I was going to have it run in a multi-story building, it would need to be in a fire-rated shaft by itself. If I use a fire-rated product, now I can run that ductwork in any shaft and as many as I want in that shaft, and even have other things inside of that shaft. So the whole game changes when I look at a fire-rated ductwork versus using a non-fire-rated duct. So even though it's outside the building without a fire-rated ductwork, I do not believe that would have to be in a fire-rated shaft because it's outside the building at that point. Can you vent multiple hoods in one duct? Yes, I should be careful how I want to turn that. Nowadays we see a lot of hoods with multiple connections, and we can combine those. I think it becomes a lot of questions on grabbing multiple hoods and running them in there because you can't run any kind of fire damper in there. So I'm going to say in most cases no, but I can have a hood with multiple pickup locations and run those in one duct. Okay, if master an old duct system had zero clearance by design, does it need to have a fire wrap? No, it doesn't. Since the product is pre-insulated, it is zero clearance as it leaves the factory. So we've got an inner liner, we've got, in that case, that project had 4 inches of insulation and an outer shell. That is already considered zero clearance to combustibles and fire rated. So there's no on-site insulation that would be added, only just to cover those gaps that they do in the assembled joints, which is supplied by the manufacturer. And I got a question, are your products ULC listed as well? Yes. All Schebler's products are UL and ULC listed and labeled. Okay, what are the field conditions that are different shown on the floor plan with the system? Since it's factory manufactured, are there variations of a few inches accounted for? In grease duct systems, we have what we call variable sections built into our design. So it would not be uncommon to obviously have a few inches of variation one direction or the other. So our engineers, when they design a grease duct system, as they would in a boiler flue system, we would account for that by having variable sections throughout the system that would allow for several inches of adjustability as the product was being assembled in the field. Next question is, it appears that the manufactured systems require extensive field detailing so that the variation parts fit in the space correctly. Is there a manufacturer's instruction for proper field modification of parts in case detailing is incorrect? Okay, other than the variable sections, okay? Our product is not allowed to be modified in the field because it would vaguely negate the UL listing. We do a lot of drawing revisions, and here we work off a 2-week lead time or less for manufacturing, and even a 5-day quick ship for extra products that would be in the floor. So for instance, it's not uncommon for us doing a large system, as like I showed in the Mass General project, where we did not design the last few sections of the ductwork that connect to the hood because the hood had not been set yet. So our system, the majority of it was shipped, delivered, received on site, installed, and then once the hood was finally set, we received final confirmation of those locations to pick up off the hood for the remaining parts of it, and then we designed, built, and shipped those within 1 week working time. I want to appreciate everybody's questions today. We're kind of running short on time. We will get to your questions and respond. I want to thank everybody for attending and hope this information was very useful. Thank you.